Okay, great. So I will begin this afternoon's session with a brief introduction. Welcome everyone to the IEA Bioenergy Webinar series hosted by the Canadian Institute of Forestry. My name is Natasha Machado and I will be kicking off today's session. Today is Wednesday, November 13th, 2019, and we are very pleased to have Chen-Lin Li, Senior Research Scientist at the Idaho National Laboratory in the United States of America, Ray Hofnagel, Assistant Professor at the Copernicus Institute of Sustainable Development, Utrecht University in the Netherlands, Fabian Schiffer, Senior Researcher at the Energy Economics Group at the Vienna University of Technology in Austria, and Olli Olsen, Research Fellow at the Stockholm Environment Institute in Sweden, who will present on future prospects for wood pellet markets. The session will be moderated by Uwe Fritsch. I will now pass it over to Uwe, Task Leader for the IEA Bioenergy Task 40 and Co-Leader for IEA Bioenergy Task 45. He is also the Scientific Director of the International Institute for Sustainability Analysis and Strategy in Germany. To begin today's session, an introduction of the session speakers.
Thank you, Natasha, and welcome everyone. Thanks for joining us. As a task leader of IEA Bioenergy, I welcome you. And before you hear the presentations from my colleagues, just to remind you, the full report on the issue of the future prospects for wood pellet markets is available on the IEA Bioenergy website for free download. So if you want to have details on what you're going to see in the next minutes, feel free to take a look to our website. And I also want to mention briefly something we are not going to discuss today, but will be part of our future work. That is the possible role of small-scale pelletization with regards to rural development, especially in countries such as Africa, for the rural development and for access to water and energy in the case of bioenergy. That is something we didn't touch upon in the future prospects report, but we will in the near future. And you have heard already about my colleagues. All are from Task 40, which is actually on deployment of sustainable bioenergy and bio-based products. We have nearly completed our first year of work and 2 more coming up. And so if you have interest to join us, to work with us, please feel free to contact me by email. My contact info is on the website of IEA Bioenergy Task 40. And the colleagues have been quickly introduced. I don't want to say much more about it to save time. And for the procedure we have here is, please feel free to enter your questions in the chat box, and we will go through them one by the other after the talks. We will not have questions after each talk. We will have a collective discussion at the end. And with that, I would like to hand over to my colleague Chen-Lin, who will start.
Okay. Thanks, Uwe, and thanks, Natasha, for the introduction. So this is Chen-Lin Li. I'm a researcher from Idaho National Laboratory of United States. So I will take the next 10 minutes or so to talk to you about the technology advancement on wood pellets, cost reduction and quality improvement. So conventional biomass production and supply for bioenergy and biopower industry has traditionally been hamstrung by supply chain issues. So the industry has always been relying on conventional biomass supply system, where biomass like woody residue, energy crops, and as well as herbaceous material, they are always available but limited to the high-yielding area, where materials are always procured through contracts with local growers and harvested, stored locally, and delivered in bale or low-density bulk format to the conversion facility. So the conventional biomass system has been demonstrated to work very well in the area. For example, in the United States, the southeast forest or the Corn Belt area. However, scaling up the biorefinery industry always require the sufficient biomass quantity and desired quality at low cost without interruptions for year-round operation. So in the last 10 years, So my lab, Idaho National Lab, with a funding support from US DOE's Bioenergy Technology Office, we have been working on advanced biomass supply system. So as I show here in this slide, so we integrate the distributed biomass processing center or facility known as Biomass Depot in the center of this slide. So the goal is to improve the quality and reduce the cost, also ensure the supply quantity of feedstock commodities to grow the future bioeconomy. So in the depot, various materials come from the woody to herbaceous and to energy crops, and also municipal solid waste can be delivered to the depot, go through multiple unit operations like in the middle, size reduction, stabilization, also the densification as the topic of today. So the high quality material in terms of solid, for the densified pellets, they can be delivered to biofuel, biopower, as well as other potential markets for application. So with the support of Biomass Depot, biorefineries actually can be built almost anywhere, including the low yielding area for biomass supply. We deal with the loose material, the low bulk density material for woody. So there are always problems in handling and feeding, and also result in high transportation cost. So densification is, as I show here, is the pellet goes through the pellet mill, which is a mechanical system. So the material can be pelletized or densified into pellets, briquettes, or cubes using pellet mill, cubers, or briquette presses. So the major challenge of the traditional biomass pelleting process is the drying and handling of the biomass to a really low moisture content for conversion system. So like I show here on the top of the slide, so this is a conventional advanced high moisture, conventional moisture pellet, high moisture biomass pelletization process. So the material, the high moisture biomass, which is higher than 30% moisture content, is conveyed into the first stage grinder for size reduction, then goes through a rotary dryer at high temperature, where the material can be dried to low moisture content to about 12%. Once dried, the material will be sent to the second stage grinder for further size reduction, and then pelletized using the steam system in the pellet mill. So our lab has been, with the researchers' effort, has developed a high moisture pelleting process. So the material, so this can reduce the grinding and the drying energy, also making the pelleting more cost effective. So in our case, the high moisture material, after grinding, can be preheated and pelleted instead of drying prior to the pelleting process compared to the conventional system. Rather than using a rotary dryer, which operates at high temperature in the conventional system, in our process, we can utilize the low temperature drying process in the green dryer or the belt dryer. So this new process can be operated at much low temperature, also reduce the moisture content to the desired range. Moving to the next slide. So if we take a closer look at the conventional drying system and also the techno-economic analysis, the pre-processing for the feedstock supply actually is the largest single cost associated with biomass feedstock, as I show on the left pie chart here. So the pre-processing includes size reduction, drying, densification. So when we take a closer look of the pelleting process, also the unit operations, their energy consumption. On the right side, so this is the pie chart of the energy consumption distribution. So the rotary dryer, as shown by the green section, it actually takes 65% of the energy consumption, while pelleting itself in the purple pie fraction, it's only 9.3%. So this demonstrate the conventional system has really high energy consumption and also the high capital cost, operation cost. So another concern for the traditional conventional system is the high temperature drying process can generate the volatile organic compounds. So this will bring to the potential hazard to human and environment. So if we look at our system, our technology advancement, the advanced high moisture pelleting has lots of advantages over the conventional process. So we actually can eliminate the rotary drying step and save capital cost and energy consumption significantly. We can handle the biomass at really high moisture content above 20 or 35%. So during the pelletization, because of the frictional heat developed in the process, it's actually natural drying process to help reduce the moisture content of the biomass. Plus, the drying could be optional if the pellets require high durable and stable format, so the pellet could be dried. But if not, the low-cost dryers, such as green or belt dryers, they can be operated at low temperature, 60 to 80 degrees C. So during the process, no VOC emission. There's reduced risk of fire and explosion. Also, the low-quality heat can be reused for drying. We can do better control over the product quality and moisture management. The process is less capital intensive. So our researchers also performed techno-economic analysis to compare and evaluate the conventional pelleting process and the high moisture pelleting process using a scenario in which 10 biomass depot is considered to support an annual biorefinery demand of 750,000 tons of biomass. So our results show, like I show here in the figure, so the biomass depot actually can process economically the biomass into pellets using high moisture pelleting process at a cost of only $31 per ton. So it's nearly 50% saving compared to the left column, the conventional pelleting process. Also, among the cost savings, the fuel cost, as shown in the purple section, the fuel cost is significantly lower for high moisture pelleting process compared to the conventional system, mainly due to the replacement of rotary dryer with a low temperature green or belt dryer. So the low capital cost using the high moisture process also result in lower interest and depreciation. Repairs, maintenance, insurance, housing, and taxes also lower for this new process. So if you have more interest, we have, our lab has published this paper in 2015. The lead author is Patrick Lammer on the TA analysis in the Bioresource Technology journal. Moving further, so I also want to mention about the pelleting quality improvement is really critical for the conversion process for biopower or biorefinery biofuel production. So our researchers, our team is led by Jaya Tumaluru, the leading scientist in our lab. So the team has been performing advanced characterization process by utilizing the advanced research tool. So this slide is an example of the pellet characterization studies. So the team, we have been using CT scans to look at the morphological and spatial characterization without destroying the pellet to help understand the surface, the chemical information of the pellet. So also the Fox M-beam tomography as well as SEM coupled with energy dispersive spectroscopy to understand the chemical information as well as the morphological structural information for pellet quality improvement also correlate with the process optimization. So it's very exciting, lots of research going on, and also collaboration with our team members in Task 40 of IEA Bioenergy. Okay, so in summary, high moisture pelleting process has too many benefits. So if you have more interest, please reach out to me. With this, I would like to transfer the presentation to my colleague, Rick Hofnagel, to share his perspective on the wood pellet current market status. Thank you.
Thank you, Chen-Lin. Hope you can hear me.
Yes.
So we looked into the details of the pellet process, and what is very interesting is that it's focused on agro pellets. But I'd like to move one step backwards towards the development of wood pellets first. So if we look to just in the time frame of also when IEA Bioenergy Task 40 monitored the development of the wood pellet market, starting in the year 2000 with less than 2 million tons. So you can actually look at today's market of almost over 55 million tons. So we see a really rapid development of the wood pellet market in the past 2 decades, roughly. As you can see from the Lamas study, which is a publication of IEA Bioenergy Task 40. What you can also observe is that it started to develop first in the European Union with increased production, followed by a ramp-up of production in the US and mainly in the US Southeast. And that was mainly driven by demand in the EU. So you see a trade flow, as I will show in the next slide, of biomass wood pellets exported to the European Union. But you can also see that in the last, at least in the you see steady growth still, but not so much anymore in the European Union on wood pellet production. The small increase in other Europe, mainly Russia, for example. But the US, the North American market did not grow anymore so much in the last few years. So it was relatively steady. That had to do with some bad weather, some expected projects that did not come online, for example. But of course, what you can see mostly is that we see another market being developed now, and it is in China and other Asia. Bear in mind that data for China is not based on official statistics. They are rough estimates based on very small pellet mills. But it shows actually that China became now the largest producer of wood pellets based on these estimates by Bioenergy Europe. So it overtook Europe as the largest producer, contributing to 36% of wood pellet production in the world, with the EU contributing to 30% today. So this is a huge increase. What we can also see is that other markets in Asia, including, for example, in Japan and Korea, take off as demand regions for wood pellets as well as for production of pellets. So if we look to current wood pellet trade, it used to be a market from Russia and the US and Canada towards Europe. But you can also see a shift there towards more Asian markets, including Korea and Japan, that require more and more wood pellets. Whilst China is still, and it's not shown here, a more domestic-oriented market, there are huge initiatives now to start industrial use of wood pellets in that region as well, which might shift also domestic production towards more agro pellets, and which is now roughly only 20% of pellet production in China towards maybe 30%. And we might see the same maybe, which is a very small production still today in South America, for example in Brazil, where bagasse might be a feedstock for future pellet production. We know that huge utilities in Europe look actually in those markets to get those being exported to Europe, for example. So the development might not only be focused on wood pellets in the future, but also we have to focus more also on the development of agro pellets. So bagasse as an example, but also with straw pellets, corn stover, as discussed by Chen-Lin, for example. And it's not expected actually that North America, so US, Canada, but also Russia, at least for the midterm, it's not expected that we see a huge increase in domestic demand. So those regions might still export. And China might actually also become an importing region of wood pellets. So we try also to just create cost structures of how, and this is also part of ongoing work, for example, by IEA Bioenergy Task 40. We try to explain how these costs are built up of wood pellet supply chain. So compare the actual market prices and actually based on literature review, but also working in close collaboration with actual suppliers, see how these costs are actually built up. And one of the limitations of today's studies available on wood pellet supply is that they are mostly focused on very small plants, or at least compared to what the big plants that have been built, for example, in the US, over almost 800 kilotons per year production in Georgia, for example, but also in Russia, where you see a big pellet mill of 900 kiloton production per year. And those cost estimates are actually mostly based on 200 kiloton production at most, so they are very different. Nevertheless, we believe actually that we can make some rough estimates of how these pellet costs are built up. And these are the estimates we published in the report of IEA Bioenergy Cost 40. So we provide a range of costs. It doesn't look into the uncertainties of, for example, exchange rates as well as the freight rates of shipping, for example. We try to just get an estimate based on today's costs. We can see actually that they are more or less in line with the CIF-ARA, so the cost of pellets delivered to the port of Rotterdam, for example. That they are mostly at least competitive for the spot price market, but also sometimes the spot prices have been lower than these cost estimates or the cost price we estimate for the supply chains. What you can also see is that the low cost estimates here, at least in this slide, are really based on very dry sawmill residues, so the cheapest and most effective sources of wood pellets supply. But bear in mind that most wood pellets actually have, or at least the feedstock supply has a higher moisture content, so it requires more drying, and as already explained by Chen Lin, there's actually a very large cost factor. It's actually the drying of the biomass, or the feedstock. If you have a feedstock of 50% moisture content, the price total supply costs go up significantly. Secondly, you can also see that the estimated supply cost of Brazil by gas pellets, so these are agro pellets shown on the right side of this figure, are relatively cost competitive with today's wood pellet supply cost based on US dollar per ton dry delivered in the Netherlands. And you can also see that actually the transport costs to a port are contributing substantially to those supply chain costs. And that mostly has to do with the distance you have to travel inland in Brazil to get pellets from the existing sugarcane mills to a port. There's actually quite a long distance in most cases. That increases the cost substantially. So maybe if those markets could develop, it also means to reduce the cost would also mean you have to develop infrastructure like maybe terminals that collect the wood pellets and then use a train network to bring those pellets to a port for export. Secondly, just as an illustration, an explanation why spot prices might sometimes actually be lower than the cost price even is basically mostly driven by the market conditions. And it's depicted in this figure. We can see the CIF-ARA spot price delivered, and we also show the contract prices. And in the area below, you can see the net difference between the contract prices of US-based and Canadian-based pellets for industrial uses compared to the spot market. And you can see actually that in the year 2017, there was a significant difference between the contract price minus the spot price of US-based pellets due to overcapacity. There was a mild winter, project didn't take off, so the oversupply led to this unhealthy market. So, but at least the profit margin of $20 per ton pellets is needed to have a healthy cash flow for those pellet mills. To summarize, we have seen the market of pellets increase from 1.6 million tons in the year 2000 to 55 million tons based on those at least rough statistics that are now available, including Chinese markets. And we see also that a geographic shift towards other regions of pellet demand and supply, so in China, for example, maybe in the future also towards other resources like the bagasse pellets from Brazil. Cost estimates we based on literature are between $100 towards $150 per ton. So we can also see actually the profit margin is at least small in normal market conditions. So that also is a challenge for this market to maintain production is really to reduce those costs still to become a sustainable market. Finally, bear in mind still that these cost estimates we rely on literature, and they are based on relatively small wood pellet mills, far below industrial capacities that are today at 900 kilotons. Nevertheless, we believe these provide very useful insights to develop supply chain costs and to see where the hotspots are of total supply chain costs. With that, I'd like to give the floor to Fabian Schiffer.
Thank you, Rick, for this market status and current development. I will now try to go a bit into the market outlook for wood pellets. So in addition to the already shown contract and spot prices, which you can find here again in the lower part of the graph, we also looked at the price development for residential wood pellets in the main wood pellet consuming countries for which prices are available online. The overall underlying research question for this part of the outlook is the following. Where can we expect these developments to go from here? The first observation which has to be mentioned is that the price collection is quite some tedious process, and a harmonized statistical methodology would be very much necessary in the main wood pellet consuming countries and eventually also in exporting countries to develop a global and mature wood pellet market. Based on the prices time series, we find the ranges for residential pellets between 200 and 300 euro per ton, for residential pellets including the VAT. For industrial pellets, we show prices below 200 euro per ton excluding the VAT. We can observe seasonal fluctuations in most countries with peaks during the heating seasons and most importantly a general trend for co-integration of the price development on the different markets. Besides this spatial market integration, we also discussed the integration between residential and industrial markets. For example, in Sweden we saw spillovers from the industrial heating market to the residential sector. The other way around is also likely to be observed, for example, in warmer winters or when the stocks are filled up and producers have to get rid of overproduction. So how can we support these wood pellet price developments to eventually end up with a fully integrated wood pellet market, which would result in a common single wood pellet price? And what would be the consequences of such a development? Within the IEA Task 40, we talked about further commoditization of wood pellets, they reaching the status of a commodity for this product. The groundwork for this process can be seen in the European and in the international standards, which define clear ranges for the physical properties different types of traded pellets are allowed to have. Standardized pellets from Croatia exhibit perfectly comparable properties to the one from Austria. However, some work has yet to be done to improve the public perception with respect to this fungibility, this interchangeability. Also, transparency is key for further commoditization, meaning that data availability and quality has to be improved, as already discussed during the last slide. Following these steps would eventually bring us to a future where the consumer can rely on relatively low and stable and at least a joint European pellet price, excluding transport costs, taxes, and the seasonal fluctuations. For the producers, this scenario holds minimized uncertainties through an extended consumer portfolio and increased capacity utilization rates of the production plant. However, market transparency and the common price also minimizes marginal profits for producers and traders. This could be dangerous for smaller and less efficient pellet production plants, while helping medium and larger plants distribution network to flourish. To round up this demand-side outlook scenario, let us talk about to which level this common European pellet price could develop. For this exercise, we looked at the last year's World Energy Outlook of the International Energy Agency. In this publication, scenarios for the production, the consumption, and the prices for the competing fuels, oil, gas, and coal are provided. According to the scenario names, the sustainable development scenario is worth striving for, while the current policy scenario outlines a future with severe and devastating climate change impact. The new policy scenario is somehow the middle ground, which will definitely still not be enough to restrict global temperature rises below our limit of 1.5 degrees Celsius. To discuss a moderate price scenario, we converted the fossil fuel prices of the new policy scenario to provide a comparison with a possible wood pellet price development. In the new policy scenario, highest growth rates are expected for the world oil price between 2016 and 2030. The price is expected to rise from about 6 to up to 14 euro per gigajoule. At the same time, more moderate developments are expected from natural gas prices from between 2 and 4 to 3 to 7 euro per gigajoule, and from steam coal from about 2 to about 3 euro per gigajoule. The prices in comparison for imported industrial wood pellets in 2016 was at about €7 per gigajoule at the ports Amsterdam, Rotterdam and Antwerp, the other ports. From these figures, we can derive that on a market with perfect competition, price parity between fossil fuels and wood pellets would have been achieved in 2016 only with a CO2 price of $60 per ton. A CO2 price in the range would actually be quite moderate. However, the average price in 2016 was at around $5 per ton and is at about $25 per ton today. For the way forward, especially the expected significant oil price rises compared to more moderate development for gas and coal could turn out to be damaging for the wood pellet market. This is because pellet and oil prices seem to be slightly coupled in some markets due to the oil consumption and transport, partly in the production, and via further indirect links. Thus, decoupling from these links and decoupling from the oil prices in general is highly recommended for biomass feedstock suppliers, pellet producers, and pellet suppliers. With this recommendation, I would like to give the word to my colleague Ole for further perspectives regarding the specialization opportunities for wood pellets. Thank you.
Thank you, Fabian. So I'd like to go further and talk a little bit about some emerging sectors in terms of future pellet markets based on some work that can be done looking into especially heavy industry, but also some exploratory work that we're doing now on the BECCS, so the bioenergy with carbon capture and storage. So the background is basically this: that we've seen, as Fabian said, you know, on the one hand, the pellet markets and the bioenergy markets are sort of in competition with other forms of other fuels when it comes to heating and power production, like oil and gas. But also there's a more positive development there is that we've seen a lot of innovation and technological development and scale up of other forms of renewables, which is in many ways as I said, it's a very positive development, but it also means there would likely be some changing conditions for the wood pellet markets in terms of where future demand might lie. So we have foreseen a rapid decrease of costs of wind and solar, and also in terms of the heating markets, which have been very important especially in Northern Europe. Heat pumps are becoming increasingly competitive, and these are also connected in a way because heat pumps are, of course, very much dependent on electricity. So if you have a very low electricity price moving forward, that might also make them more competitive. So it's sort of a potential tension there between the sort of the development of pellet markets and the extent to which sort of we have a general societal electrification. So we've been sort of doing a scoping into what we might see in terms of pellet demand in other sectors. We're looking into, again, heavy industry, and I will take some examples from the steel sector, and then also say a couple of words about BECCS. So steel is pretty interesting for me because it's been receiving fairly little attention in terms of decarbonization up until, I guess, a couple of years ago when it started to be a lot more focus on it. So it's generally, I think the general assumption is about 7% of global CO2 emissions originate from the steel industry, and the vast majority of that comes from pretty much one chemical reaction, which is the one that takes place in the blast furnace, where you have iron ore that's combined with carbon from coking coal, and which is combined to form pure iron and then carbon dioxide, so vast amounts of carbon dioxide. In terms of, so that's the sort of the dominating process. You might say that you also have two more additional processes, one called direct reduction, where you basically use natural gas, and the third one is electric arc furnace, but that is, can only utilize scrap. Well, it's mostly based on scrap, so it can't really use an iron ore process. So in terms of decarbonization of the steel industry, and I guess in heavy industry in general, you can see that there are two possible routes that have been identified in the literature, you basically do either a pretty radical process shift where you sort of take away the whole blast furnace and replace it with something else, or you try to keep the blast furnace and do some gradual reduction within that particular technical infrastructure. And interestingly, depending on how you, to various extents, but biomass and pellets can play a role in both these routes, although it will likely not be the main component in either. So in terms of looking at routes towards zero emission steel, I guess the first route, which is sort of the gradual reduction, keeping the process and then adding, is basically to keep the blast furnace and add CCS. The thing, though, is that even if you do add CCS, that is carbon capture and storage, it's pretty much limited to about 80% emission reductions in a steel mill, and that is sort of the best case scenario. But there is the opportunity that if you combine the CCS with a biomass, the use of biomass in the blast furnace, you can reach 100%. Though it is important to note that the biomass used, the pellets or whatever biomass you use in the blast furnace would primarily not replace the carbon used to reduce the iron ore. It would mostly be about injecting. So what you also do in a blast furnace, that's from the bottom, you inject carbonized coal, pulverized coal. So and this is mainly for process heat, but also to add another source of carbon. But in terms of completely replacing the coke in the blast furnace with a biomass, a pellet of some sort, could charcoal, for example, that's really not likely because it's generally perceived that the structure, the physical structure of a biomass-based charcoal product or a torrefied product would not really be sufficient to handle the stresses from this basically in the blast furnace, a pile of iron ore and coke and various additives that fix upon each other that has to be structurally solid. So that's basically the problem there. But there could be an opportunity to inject a lot of the biomass from below. So that is a potential source of demand moving forward. And as for the second route, in terms of this sort of radical shift in process, one that's becoming very popular, it's realization that this might be a really interesting route. Several steel companies in Europe are now looking into hydrogen direct reduction, which is basically that you take away the carbon part of the reduction process in the blast furnace, and instead you have a completely different process where you basically use hydrogen to reduce the iron, which has the nice side effect that your byproduct is water and not CO2. However, that only takes you to the iron. So if you want to go from iron to steel, you have to add carbon, and that's another issue where you would like to have a biomass of some sort where pellets could play a role. In addition to this, there are other steel processes that are a bit more niche that are being explored, where they're exploring the use of biomass. However, there's a very particular process called the Höganäs process that currently uses natural gas and coke, where there could be a potential to use biomass. The thing there, though, is that this process is based on gasification, and from consultations that I've been having, it seems that for that particular reason, pellets might not be what's most interesting there. You might want to go for something that's a bit low cost, so if you're anyway going to gasify it. So the idea is basically that you would have a more feedstock agnostic process. So then you would rather go for something else than pellets, which is fairly high cost. All right, so another potential source of demand moving forward is bioenergy, carbon capture and storage. And the background here is basically that if you look at the IPCC and the studies that they're doing and also other studies, is that we're likely going to need negative emission technologies of some sort, carbon dioxide removal from the atmosphere to stay within 2 degrees. And especially if you want to talk about 1.5 degrees, we're certainly going to have the need for negative emissions. In terms of the technologies that are, there's a fairly long list of technologies that are possible, but I would say the one that is most closely to commercialization among the sort of more technical ones is this bioenergy carbon capture and storage. You also have direct air capture, which is an interesting contrast to bioenergy carbon capture and storage, which you maybe can step into a little bit in the discussion. But BECCS is definitely one thing that could be moving forward, be a source of demand, especially I would say in power stations where you already have an existing biomass combustion scheme. You would then, if you then add the carbon capture and storage component to that, you have a negative emissions plant that could be certainly an added source of revenue and in terms of and relevance moving forward. And I think this is one of the underlying reasons why Drax Power is piloting BECCS at their very, very, very large plant in northern England. However, of course, the slight drawback of negative emissions is that you would have someone. It doesn't really make any sense from a business perspective unless someone pays you to sequester those emissions. And currently there isn't really that kind of there isn't really a mechanism in any policy structures that would allow you to actually get some sort of revenue from sequestering carbon. So that is something that clearly has to be addressed if we want to have a negative emission technology deployment. You have to need something. You need to have a policy scheme that sort of covers the operational expenses. And in addition to that, so yes, so carbon capture storage is basically you sometimes get the impression that it's somehow rocket science. It's clearly not, but so it's been employed in quite a wide array of markets and quite a array of sectors. The actual use of bioenergy carbon capture and storage in a power station fueled by biomass, that is not commercially at a commercial level yet. So there would be probably some need for public funding for if you want to have take basically bioenergy carbon capture storage from a piloting to a commercial level. You need to sort of cross this infamous valley of death where you have to scale up and build demonstration facilities, and that's sort of it's a kind of a difficult niche really for funding because there's a lot of money that needs to be expended, but it can be a bit risky. So that's whether we would see a large demand of wood pellets moving forward. We would then that would depend on the actual level of a policy mechanism for negative emissions. All right, thank you.
Thank you all for the presenters. We have collected a few questions which we will go through one by one, and feel free to enter more if you want to, and we will try to ask them to answer them. And also the oops, I'm trying to make a copy. And also see there is a kind of information on who is participating from which institution. And with that, I guess we can go ahead and start with the questions and the answers. The first has been from Sing San. The question, to what extent would the market change if a new or the current U.S. administration would come back to the discussion on the Paris Agreement, and to what extent is the co-firing an issue which in the U.S. hasn't been taken up? Are there reasons for that? Maybe Chen-Lin, you can react to that immediately.
Okay, sure. So thanks for the comment and the question. So this is Chen-Lin. I can help address some give some answers of explanation. So yeah, it is true. It's a challenging part that the current administration promotes clean coal technology. But I would like to mention, like the American Coal Council, they have been always looking into the technology, also the strategies by integrating biomass in the co-firing as an emission reduction strategy. So if we look at industry, I think there are still companies they're still doing really good work on the pellet pellets, producing pellets, and for desertification of biopower. So Ole actually mentioned about the Drax group, which is based in UK, but they are actually importing millions of tons of wood pellets to UK and to burn and to pack in Europe. So I think there are also companies like Virginia-based Dominion Power. They have been looking into the biomass operation to utilize the tree for the near future. Another industry, I think, so there's a Boardman power plant in Oregon. So it's part of Portland General Electric. So they have been looking into the biopower co-firing process. And so those are some industry development in the current situation. But I would like also to mention the government is also looking to providing support. So like the DOE Bioenergy Technology Office, the recent few years, they actually initiated a new program on biopower and to fund the national lab and to look into the densification also for co-firing biopower application. I think there are some promising paths forward, and hopefully there are more support from the government, from the industry to help promote the research and also the development of the pellets and for biopower co-firing application. Yeah.
Okay, thanks. Regarding the next question, regarding the Paris Accord, I guess the domestic market in the US, we have seen a decline of coal because of the price competition with natural gas, which is very different compared to Europe. So that is something where I would expect in the moment, if and hopefully that will be the case, that the US joins again the Paris Agreement. There may be some local take-up, but it will not be much, clearly not in the order of 100 million tons. It may be 10 or so. It's quite different in Canada, where there are some plans to completely convert coal plants into biomass plants. That's why some of the Canadian potential may be used locally. So that should do for that answer. The next one on the price, is it something, Fabian, you want to react to?
So I'm trying to get in here again. Which one is
the question was, based on the price, without policy support and subsidies, biopower cannot compete with fossil fuels. Is there a hope to cut down the pellet price in the near future?
Okay, so I think this was actually the question of this webinar and of our work. We tried to find what's the margins and how can we reduce these margins. So to summarize this webinar, we have the three different approaches very discussed here. The first one is the technical advancements, which Chen Lin presented to cut down the cost. Then I went more into the commoditization process, so to have a real commodity and a real global or European wood pellet market with one wood pellet price. And the third part was the specialization from Ole, so specializing in terms of finding new niches. So these are the three strategies to go for to actually find a competing advantage.
Okay, thank you. Shane had a question, and also Tozin, regarding the wet, the high moisture pelletization. Again, Chen Lin, is it something you want to respond to? Why aren't more companies doing this if it's so much cheaper?
Oh, okay. This is so high moisture pelleting is a relatively new technology. Our lab has been developing. So right now the scale is relatively small, and we are working with some industry partners to look into further scaling up and for a larger scale application. So one case is like the California, the recent wildfire. I mean, there's very severe environment and hazard issue. So there's some opportunity to work with California on this application direction. Also, the high moisture pelleting is promising. We also look into feedstock beyond woody material. So like the municipal solid waste, we are working with industry partner like Fucrom Bioenergy, looking into the municipal solid waste and high moisture waste material for application. So there are some ongoing collaboration with partnership with companies. So so far it's been promising, and please stay tuned, see how this technology development go at a larger scale. Thanks.
So there's hope. Thank you. The next question was from PJ regarding the influence of the sustainability criteria under the new EU RED II. Well, actually, in the moment, there is a lot of research going on and some internal discussions in the EU with the member states on how to implement the RED II, and part of that will be what is a sustainable forestry operation, which then would allow you to continue exporting to Europe. So we expect some sort of guidelines coming out from the Commission next spring, in maybe March or so. And if somebody of you has time, on next Wednesday, we're going to have with the European Technology Platform, we have a meeting on Wednesday afternoon in Brussels where we exactly discuss that issue. So you're invited to be there. In the moment, we can only speculate. A few months from now on, we will know better, and then clearly this is an issue we will take up in IEA Bioenergy. The other thing I want to answer is a question from Niels Gierstein. If the construction sector is resource intense and causes a lot of emissions, and we substitute for wood there, replacing steel and aluminium and concrete and so forth, would that kind of be a shift away from the bioenergy use? Well, for the pellets, at least for the majority of the pellets, they actually come from the production of building materials from wood. So all the sawdust and the other residues and co-products from the wood industry, we actually see that it's not a contradiction. It's actually a co-benefit. So if you increase the wood construction, which you should, and some countries have actually started doing so, in Scandinavia and quite a lot, in France, the uptake is there. Other countries follow. Then we actually get more material for the bioenergy use, so as co-product of that. So it's not a contradiction, it's both. Well, I think that was it right now where I had, that's Alexander Garcia asked the question, to what extent particulate matter reduction could occur by adding kaolinite to the thing. Any one of you guys has an answer to that? Maybe Chen-Lin again?
Sure. I haven't seen this publication. If you, Alexandra, if you could share, send me an email, so that would be really great. But I think this sounds a really good technology development to reduce the emission of the particle matter. I think it would definitely be beneficial to reduce the emission problem. Yeah, I will look into that. Thanks.
Okay, thank you. Then we have a question from Hannah Torop-Bowles about black pellets. And actually in the report we have published, we have a whole section on what is called torrefaction. So the even more denser, the even higher densification of woody material into so-called black pellets. And we see there is a huge prospect for that. They also have a cost reduction potential. In the moment, there is not much of a production yet because the markets aren't there ready for the uptake. But if you read this chapter in the report, I think you will find that we see there is a future under certain circumstances. And if we assume a large deployment of biomass for bags, for example, or for the steel industry, or high temperature industrial heat, we clearly need to consider better logistics, and torrefaction is one option in that. Then I think you also would have to take a look to the comment from Jim Smith from the US DOE. I won't repeat it, you can read it on yourself. That's quite an interesting comment, I guess. And with that, I guess we have gone through all the questions. Yeah, and there was a question on the slides, which I already answered. So we will make all slides available on the IEA Bioenergy Task 40 website. You see the link in the chat. I expect that Monday at the latest, we will have them ready for you. And as mentioned, from the website, you can also download the full study.
Well, there was one more question from...
Go ahead.
There was one more question from Nils Kirstein.
Oh, yes, I see that. I just have to make a copy, but I can read it better than in this mini box. Okay. Yeah. Well, the question is, what do you mean with expectation, Niels? If we assume that what we have heard from the new European Commission, that they would like to increase the price of carbon, the new Green Deal and all that, and if we see the dynamics in the moment in Southeast Asia, then I would say yes, there is a huge potential because there will be some price signals which will carry on pellet productions. On the other hand, we don't see much stimulation on the construction materials, unfortunately. There is no stimulus other than, you don't get a carbon credit or anything. So it depends a little bit on the policies of the member states. There's actually a disconnect between the building material markets or the overall bio-based products market and the bioenergy market. That is a challenge. So I wouldn't expect in the very near term, the next years, that this will be bridged. But in the longer term, if we want to achieve Paris Agreement, we clearly have to do a better integrated policy in that regard. I hope that answers the question to some extent. Okay, some people are typing. Let's see what, okay. We still have 2 minutes for if someone has a question or a response. Good. And maybe regarding this co-firing issue, I should say that there is clearly one implication for the biomass use, bioenergy use from pellets in the European Union. The new RED II requires not only a greenhouse gas emission reduction minimum, but also a minimum energy efficiency for the overall co-firing system, and that may restrict the co-firing in existing old plants. And that may have a little influence, for example, if you go to Central Eastern Europe, where co-firing has been considered. But with the implementation of the RED II by 2021, that will not really be a big market. Okay, looking at the time, we are approaching the end of the session. unless someone has a last question we want to answer. Okay. Andy Rosen, let me just copy your question. Oh yeah, very good. That's one of the things we actually address in IEA Bioenergy and have taken up this challenge to better communicate what the carbon balance over time for example, for pellets, but also for other biomaterials and used for energy is. And that is something we have to improve, and we promise we will work very hard on that. So stay tuned. And I hand over to the moderator.
Okay, great. Thanks so much, Ewan, and thanks so much, everybody, for the great presentation. So this will bring our session to a close. If you have not already, please fill out the poll on the left-hand side. So it's just by the chat pod there, following the section or the sector that best represents the nature of your work. So the poll's there on the left-hand side. If you haven't done it already, please fill it out for us. Thanks so much. And so that brings the session to a close. So with that, I'd like to thank Uwe, Chen-Lin, Rick, Fabian, and Oli for the great presentation today. That was the IEA Bioenergy Webinar series hosted by the Canadian Institute of Forestry. Thank you all once again for joining us, and have a great day. Thanks so much, everyone.
Thank you as well. Goodbye.
Thank you.
Thank you. Bye.
Bye, everyone.
Thank you. Bye.